Example 1.1 will give us a chance to be able to see a couple of sets, as well as some of the element of and is not an element of notation. And the example starts with defining two sets, and we can see here that set A is 1, 2, 3, 4, 5 elements, and set B is 1, 2, 3, 4, 5, 6 elements. So these are not sets that are infinitely long. They don't continue on forever. They do have a stopping point in terms of the number of elements that they have. So that's why these qualify as being finite sets. So what you'll find here in this section is that when we introduce a new concept, we will first do so using finite sets, and then we will do an example with infinite sets. The majority of this course will be dealing with infinite sets, but if we can get our head wrapped around what's going to be happening in the finite world, it will make it that much easier for us to translate it into the infinite world. So that's going to be the direction that we'll be going. So the actual question for these is to determine if each statement is true or false. So when I look at statement A, I need to read it and check to see if the statement is true. So as I read this statement from left to right, it says 3 is an element of set A. So I'll come up here to set A, and I can check to see absolutely 3 is one of the elements that's in set A. So I would certainly say that this is a true statement. Looking at part B, we have that 3 is an element of B. If I go look at set B, I don't see 3 as one of the elements at all. So this represents a false statement. Looking at statement C, this has the is not an element of, and this is claiming that 4 is not an element of set A. However, I can see that 4 is actually an element of set A. So this is a false claim. The examples we just did, A, B, and C, these are all single statements. Parts D through G, are called compound statements. They're called compound statements because they have more than one statement. And you will notice, as you look at D through G, there is one of two different words that can appear in between your two statements. We have the word and we also have the word or. When we're dealing with a compound statement, you must first identify the validity of each statement individually. Then you check to see how does the word and or the word or then give us the validity of the compound statement, which is both of the statements put together. So let me go back to part D where it says 1 is an element of A. That's the first statement. Let's check to see if that's true or not. 1 is an element of A. And yes, I see that 1 is an element of A. So this statement on its own is true. The second statement says that 1 is also an element of B, which I see is also going to be true. So both statements individually are true, but as a compound statement, I have to think about what does the word and require me to have. Now the word and requires that both of my statements be true in order for the compound statement to be true. So since both of my individual statements are true, I can now justify that the compound statement is also going to be true. Now take a look at part E, and we'll go through that same process. I take a look at 0 being an element of A. That is false. And I check to see if 0 is an element of B. which I do find to be true. But the problem here, again, is that I have an and that connects my two statements. And the word and requires that both statements be true in order for the overall compound statement to be true. So this ultimately gives us a false result because I don't have both statements being true. So now let's switch over to the or statement. We'll take a look at the first statement here for part F. -2 is an element of set B. And yes, I can see that -2 does appear in set B, so that statement is true. And for the second statement, -1 is an element of A. I don't see that being, I don't see -1 being an element of A, so that statement by itself is false. But if I look at both statements together, which are being connected with the or statement does not require both statements to be true. All it takes is one of these two statements to be true, and it makes the overall compound statement true. So in this case, we do have one of them that's true, which means that we can conclude that compound statement is true. And the last one we'll look at is part G, another or statement. If we take a look at 0 being an element of A, that is false, and 3 being an element of B, that is also going to be false. So here we have both statements false, and since neither one of them are true, that means that the overall compound statement is also going to be false.